Okay, so this lesson, solving rational expressions. First example. B over 2 equals 1 over 3 plus 6 over b. First thing we need is a common denominator. Our coefficients are 2, 3, and 6. What is a common denominator between 2, 3, and 6?
It's going to be 6.
6. I also have a b here, so I need, what else do I need?
A b.
So my common denominator is going to be 6b. Alright, so if I multiply all these by 6b, and I'm doing this to clear my denominator. My first one, 6b over 2, what simplifies?
The 6.
The 6 and 2 simplify, leaving me with
3b.
So I'm multiplying my first one by 3b. So 3b times b is 3b squared equals my second fraction, 6b over 6. What simplifies?
6 over 3,
Okay, so I'm left with 2b. So 2b times 1, 2b, plus 1 over 6b. What simplifies?
The 6b's cancel out.
6b simplify completely, leaving me with just 1. Alright, so now you have a quadratic here. It almost looks like a polynomial. What do I need to do?
You have to bring the 2b and the 1 over to the other side.
Excellent. Let's set it equal to 0. So we can set this equal to 0 by saying 3b squared minus 2b minus 1 equals 0. And all I did was just bring these over to the left side of the equation, leaving my b squared positive. Okay. Now we got to factor 3b squared minus 2b minus 1. You can use the AC method, or you could just try to go right into it and see if you can figure it out on your own. This is nice because your leading coefficient is prime, and your last number is also prime. So when you factor this, what are factors of 3b squared? 3b and 1b, or just b. What are factors of 1? Well, in this case, the only factors of 1 are 1 and 1, so this problem works out nice. So now you just got to figure out my signs. Are my signs going to be the same or opposite? Opposite signs, and I know they're going to be opposite because my negative sign here. Now I just got to figure out, I want my negative 2 to be negative, so 3 times b is 3b squared. 3 times 1 is negative 3b, plus 1b will give me my negative 2b. So 3b plus 1, b minus 1 equals 0. One last step, take each factor, set it equal to 0. So 3b plus 1 equals 0. b minus 1 equals 0. Solve both of these for b. b equals negative 1/3. b equals positive 1. So n plus 4 over 2n cubed minus n cubed equals 1 over 2n. What is my LCD here? What is my LCD? 2n cubed. Very good. So my LCD is 2n cubed. My coefficients are 2, 1, and 2. What's the least common denominator between 2, 1, and 2? It's going to be 2. My variables are n cubed, n to the first. Take the one with the most. Who's got the most? N cubed. So n cubed is what I need. I'm going to multiply all these by 2n cubed. All right. If you want to multiply all of them by 2n cubed separately, that's fine. So rather than doing that, you could say, okay, sometimes this might be easier for some of you guys. So times 2n cubed times 2n cubed times 2n cubed. However you want to go about it. So 2n cubed over 2n cubed. What simplifies? Everything. 2n cubes both simplify, leaving me with just n plus 4. Minus 2 over n cubed, 2n cubed over n cubed. What simplifies? N cubed and n cubed. What am I left with? 2 times 2, or 4, or negative 4, equals 2n cubed over 2n. My 2 simplify, and 1 of the n's simplify, leaving me with n squared. N squared times 1, n squared. Alright, so now I'm getting closer. Now this is a nice little hint right here. I have a square there. Alright, so let's bring everything over to that side. Before I bring everything over, can I combine any like terms on this left side here? Yeah, positive 4 and negative 4 is there, so I'm left with n equals n squared. I'm going to bring my n over to the squared side, so minus n, and this is going to leave me with I'll bring it up. N squared minus n equals 0. I don't have 3 terms. I only have 2 terms. There's 2 things I could be thinking. One, factoring out, or a difference of perfect squares. Is this a difference of perfect squares? No. What can I factor out? Good. I'm going to factor out n, leaving me with n times the quantity n minus 1 equals 0. Again, I have 2 factors here. Split them up. N equals 0. N minus 1 equals 0. N equals 0, that's one solution. N minus 1, add 1 to both sides. N equals 1 is my other solution. Now, before we go about, can n equals 0 be a solution to this?
No.
It cannot be a solution because that would create my denominator to be 0. So we can't use n equals 0, so my only solution is n equals 1. Alright, so our next example, n squared plus 4n minus 5 all over 4n minus n squared minus 4n plus 4 over 4n equals 1, if I want, 1 over 1. First question, what is my LCD?
4n.
4n, nice and easy. So I'm going to multiply all these by 4n. And multiply this by 4n. So, what simplifies? 4n over 4n? Everything simplifies, leaving me with just n squared plus 4n minus 5. Next term, 4n over 4n, simplifies again. Very important. These parentheses around this quantity. Alright? Why? Why are those very important?
Because now the negative, you have to distribute the negative.
Very good. This negative right there, you have to distribute. Very good.
If you distribute that, then you can change the whole problem.
So minus the quantity n squared minus 4n plus 4 equals, if we wanted to, we could put these in parentheses, and then 1 times 4n is just 4n. These parentheses I just added here, can I drop these?
Yes.
Yes, there's a positive 1 in the front, I could just drop those parentheses. Let's get that one down. So n squared plus 4n minus 5. Distribute the negative to all terms inside the parentheses. Minus n squared plus 4n minus 4 equals 4n. Simplify, combine like terms. N squared minus n squared, see you later. 4n plus 4n, 8n, negative 5, negative 4, negative 9 equals 4n. Solving for n, bringing n's over to the other side. So I'm left with negative 9 equals negative 4n. All I do is subtracting n from both sides. And my last step here, divide both sides by negative 4. N equals 9/4. Our next example, 1/2 equals k plus 4 over 10k plus 3k squared plus 9k plus minus 12. Alright, LCD. My coefficients are 2, 10, and 10. The common denominator, or the least common denominator between those 3 numbers is 10. This does not have a k, has a standalone k, has another standalone k. The greatest exponent on the k's is 1, so I'm just going to take k to the first power. Only one time. I'm not taking 2 of them, only 1 of them. Multiplying everything by 10k. Okay, what simplifies? My 5 and my 2 and 10 simplify to 5k, so 5k times 1 is 5k equals. My 10k simplify here, leaving me with the quantity k plus 4 plus, and the 10k's here simplify, leaving me again with the quantity 3k squared plus 9k minus 12. Now, great practice would be usually to put these in parentheses. I avoided the parentheses here simply because in front of the k plus 4 there is nothing but a plus sign. In front of the 3k squared plus 9k there's nothing but a plus sign as well. So those parentheses can be dropped without distributing a negative like in the last example. So let's combine like terms. We got 5k equals, we have k, 1k, 9k, we have 3k squared plus 10k minus 8. I'm going to bring the 5k over, so I'll have 3k squared, there should be a k here, plus 5k minus 8 equals 0. And I was just subtracting 5k from both sides and leaving me at this point here. Now, can we factor 3k squared plus 5k minus 8 You can use the AC method at this point, or you can try to factor mentally. So factors of 3k are 3k and k. Now factors of 8, so if you look at this, your factors are 3 and 1 for k. Factors are 1 and 8, 2 and 4. So of these factors, is there any way I could get a positive 5k out of here? Well, let's take a look. If 3 times 1 is 3, 1 times 8 is 8. So 8 and 3 can give me 4. So I want my 3, can give me 5. So I want my 3 to multiply my 1, and I want my 8 to multiply my k. So when I distribute 3k squared plus 3k, and I want this to be minus 8k, and that will give me my 5k that I have here. So I have 3k minus 8 times the quantity k plus 1 equals 0. 3k minus 8, set that equal to 0. K plus 1, set this equal to 0. Solve for k here. K equals 8 over 3. And k here equals negative 1. Make sure these are not extraneous solutions. The extraneous solution here is if k cannot equal 0. So both these solutions work. Next example. 4 over x squared plus 4x. 1 over x squared plus 4x minus 1 over 1 if you want to put that 1 there. Typically you should factor these as much as you can. However, since they're both the same, I'm going to leave them the way they are. So my LCD here is just going to be x squared plus 4x. Now multiplying through by x squared plus 4x. Multiplying this one by x squared plus 4x. And my last one, x squared plus 4x. These simplify, leaving me with just 4 equals. These simplify. 1 minus the quantity x squared plus 4x. Be careful, make sure you distribute your negative all the way through. So I got 4 equals 1 minus x squared minus 4x. I'm going to make my x squared positive, so I'm going to bring everything over to this side. So positive x squared plus 4x, and this is going to be minus 1 plus 3 equals 0. And then you can factor this into two quantities, x plus 3, x plus 1 equals 0. And then your final answers, you're going to have x plus 3 equals 0, x plus 1 equals 0. Here you see that x is equal to negative 3, and x is equal to negative 1. Let's make sure that these both solutions are not extraneous solutions. X squared plus 4x. So 1 does x squared plus 4x equals 0. Well, we can factor this. It would be x plus 4. So when x is 0 and x equals negative 4, we have extraneous solutions. So x cannot equal 0, x cannot equal 4. Both solutions here are good to go.